Hey everybody, welcome back to another week of math. Hope your weekend went well. So we're starting a new unit of instruction. In the book, if we were using it, it would be chapter 2. Actually, this is going to be broken into two separate units. So we'll do several sections and have a test on it, and then we'll continue in what I'm going to call unit 2, and later on have another test. Fair warning before I go too much, for whatever reason today, I'm at home right now. My dogs are just full of energy. So if you hear running around, barking, their tags jingling in the background, I'm sorry. I hope it's not too much of a distraction. Okay, so today we're doing an introduction to functions, intro to functions. And what is this? 1, 2, 3, 4, 5, or maybe even 6, since there's an and here, things that you're going to be expected to learn today. It's all pretty easy, and there's not much lecture that I'm going to do. I'm just going to get straight into the examples, and I'm going to use those to explain pretty much everything. But we are going to look at, sorry about that, different ways to express relations, ways to determine if a relation is a function, how to determine what is referred to as the domain, I didn't mean to do that, what is referred to as the domain and range of a relation or a function. Use something called the vertical line test to tell if a relation is a function, and then determine the difference between what are referred to as discrete and continuous functions. Or to be quite honest, this should be relations. And I'll talk about that in a minute. As far as your homework, though, your homework is going to center on these three items here. The first bullet point I'm going to talk about as we go through, and the last bullet point I'm going to talk about as we go through, but those aren't things you're going to be tested on or have to do homework with. The middle three is sort of the main point. Okay, so let me take you to this worksheet, and I'm going to scroll through really quick, and I'm not trying to scare you. This is a lengthy piece of work here, but the problems go really fast. The exercises go really fast. And there's 25 of them. There's not 26. I know normally I do all of the evens and leave the odds up to you. So there is going to be no 26 for me to do. Maybe when I get there, I'll make up something at random just so it seems fair. Okay, so we are going to start at the top. This says worksheet 4.1. That would be 2.1. That's a small issue, whatever. This was something that was originally supposed to be printed off. That's why there's a place for your name. You don't have to write your name in there. But please don't forget when you're done to write a score. Either put it up here somewhere that I can see it, or obviously use the comments. Okay, let's get on with this. So 1 through 4, these are all what we refer to as ordered pairs. So it's a list of points. As you know, a point is an x and a y coordinate that are plotted on a graph, put in parentheses with a comma in between. So these are all points, or again, what are referred to as ordered pairs. As I mentioned, we're going to talk about ways to express relations. So one way to express a relation is just to make a list of ordered pairs. Normally they go in front of these funny things called braces. So this is one way to express a relation. So a relation is a bunch of pairs of numbers. So here's a pair, there's a pair, another one, another one, another one. If you pair numbers together, then what you've created is a relation. Anything that pairs numbers together, therefore, can be called a relation. So you're relating one number to another. Before I go any further with number 2, if I had you all in class right now, and so maybe 20, 25 of you in the room, and I had you get out a sheet of paper, and I said, okay, put down a parenthesis, then put down your age. Some of you put 16, 17, 15, 18, whatever, how old you are, and then a comma, and then the last 4 numbers of your phone number, 1, 2, 3, 4, whatever that is. That's kind of random. I mean, your age isn't random. I mean, it's a specific thing, but there's no rhyme or reason. But just because I wanted to, if I had you all do that and then you handed in the papers, I would have a list of, like I said, 20, 25 students, 20 to 25 ordered pairs of a number followed by the last 4 digits of your phone number. And that would be a relation. it serves no purpose whatsoever other than for me to come up with a random example, but that is an example of a relation. Now, normally the numbers do have something to do with each other. For example, like maybe like age and some sort of numerical computed risk of heart attack or something like that, or I don't know, level of education, 0 through 12, maybe 13, 14, 15, not to represent 13th grade, but years in college in addition. So like years of education, comma, annual income or something like that. Two things that maybe could be studied to see if there's a relation or a relationship between those numbers. So that's a relation. So anything that pairs numbers together is a relation. Some relations are called functions. So a function is a special type of relation that follows a specific rule. So you know what I'm going to do? I'm going to come up here and I think I'm going to write down the definition of a function. I said there weren't going to be notes, and now I changed my mind because that's what I do. In fact, I'm going to write a definition of relation. I'm going to keep it simple. I'm not going to give you like you're reading a textbook or a math definition. So a relation is a group of pairs of numbers. That's it. A function is a type of relation. So I'm going to start definition of function. It's a relation where each x value is paired with exactly one y value. So if I wrote down 1, 2, 5, 8, this is an example of a function because each x value is paired with one y value. If I wrote down 1, 2, 1, 8, this one is not a function because an x value 1 is paired with two different y values. So another way of saying it, in order to be a function in a relation, you cannot reuse an x value, or you can't use an x value twice. So I'm going to put that as a little asterisk. So putting it in as simple of terms possible. In a function, you can't use an x value more than once. Okay, now I think we can actually get to the example. All right, so determine if the following relations are functions. Number 2, let's look at the x values. 1 is used, 2 is used, 3, 4, 5. Are any of those used more than once? No, they're not. So yes, this is a function. It's that simple. Now, we are asked to state the domain. This is also easy. Domain simply means x values. Oh, my handwriting, good grief. X values. So to state the domain, you put one of these funny brackets down, braces as they're called, and we're going to write 1, 2, 3, 4, 5. And that's that. That's the domain of that function. If domain is x values, what do you think range is? I'll give you one guess. If you guess wrong, well, it's okay. I still like you. If you guessed y values, you are correct. So in this function number 2, the range is 1, 2, 5, 10, 15. 1, 2, 5, 10, 15. If you can't make braces, just do little squiggly lines and that's fine. But that's it. Number 2 is done. Let's look at number 4. Is this a function? Well, look right here. -3 is an x value twice. You cannot use an x value more than once, so no, this is not a function. It still has a domain and range. Domain is the x values. So the x values are -3, -3, 3 halves, and 5. Now, if a number does get repeated when you give the domain, you don't have to write it twice, like -3, -3. That's not necessary. Just write it once. -3, 3/2, 5. And see, that bracket looks really dumb, but I can do a better job. But if you can't draw that, again, no pressure, just whatever. If you just need to list it, so like the range is the y values. On your homework, if you want to write 2/5, 3/5, -5, 2/5 again, you don't have to write it twice. That's good enough. I would accept that as a right answer. It's cool. If you can do the brackets or braces, man, if I could only say the right thing, it would look like that. Oftentimes, when you go to check yourself, you'll find out that the author of the worksheet, that whoever published it, they put the numbers in numerical order. So -5 is the smallest, followed by 2/5, followed by 3/5. That really doesn't matter. That's splitting hairs. I don't care. You don't have to put your answer in order like that. But if you want to, you can. Okay, so you are going to be asked to do 1 and 3, just the way I did 2 and 4. Before I go much further, I want to tell you that these are referred to as discrete functions. Discrete means there's a finite number of points. Finite means you can count them. So this has number 2 has 1, 2, 3, 4, 5 points. It's discrete. 1, 2, 3, 4 points. It's discrete. What's the opposite of finite? Infinite. So if there's infinitely many points, it's not discrete. What am I forgetting? Am I forgetting anything? Ways to express relations. Okay, so the way to express this, I'm just going to highlight it in, let's use bright pink, ordered pairs. These relations are expressed as ordered pairs. The next couple are also relations. They are expressed as a graph or graphing. It's weird to see ing on the end of a noun. It's a graph, but people say it's a graphing, so whatever. So state whether it's a relation. Oh, I'm sorry. Wait, what? Write each of the following. Oh, I didn't read my own directions, for crying out loud. Write each of the following as a relation. So we're going to rewrite this like that. So that's our first step down here. So the relation is going to be this point up here, which is -2, 3, followed by this point right here, which is 0, 1, followed by that point, which is 2, -1, followed by that point, which is 3, -2. And again, wrap the whole thing in braces. Let me make a neater one here. Well, okay, I don't know why I did that. There we go. Okay. What's the domain? The domain is just the x values. -2, 0, +2, 3. Oops. What's the range? Range is the y values. 3, 1, -1, -2. And is this a function? Well, let's look at the x values. Are any of the x values used more than once? No, they are not. 2 and -2, remember, those are two completely different numbers. So yes, this is a function. Now I just realized something. My typical way of teaching is to do a problem, or sometimes two, and then check the results, and I've not done that. This worksheet is so long, I gotta scroll way down. So I'll try to check 2 and 4 right now. I kind of know they're right, just because I do this all the time. So you can see these are discrete. Yes, domain and range. No, domain and range. Oh, look. That's written twice. Normally that's not done. I'll be honest with you. That's not typical. So, yeah, that's fine. And then number 6 I just did. So here's the ordered pairs, domain, range, and yes, that is a function. Is that the same as my answer? Yeah, okay. Oops, I guess I need to put a bracket there. All right, let's look at number 8. So the relation. There's 1, 2, 3, 4, 5 points. So let's see. Let's do this point first. That is -2, -4. Then we'll do that point next, -2, -2. This point is -1, 1. That point is 1, -2. And the final point there is 3, 0. Parenthesis, running out of room, squeeze in a bracket, put a comma, and we'll call that good enough. The domain is a list of all the x values. So we've got -2, followed by -1, and then 1 and 3. The range is just a list of all the y values. So that's going to be -4, -2, and then 1, -2, 0. Oops. Okay, I don't have to write -2 again because we already had it once. So I'll just put 0. Okay. Next, is this a function or not? Now, what's important to remember here is x values. You cannot use the same x value twice or 3 times. You can't use the same x value more than once. It's okay to use a y value more than once. The fact that we have a -2 here as a y value and here is totally okay. That does not violate the definition of function. However, we do have the same x value twice. So no, this is not a function. Let's check number 8. Sort of throw that in your short-term memory. And yeah, I'm going to call that good enough. Well, here, the range again, value is written twice. You don't need to do that. Though something messed up. Yeah, the answer key is wrong here. Go figure. There should be a 0 for that point right there. And, oh, I think the person who made this overlooked that point. So this should be extended. It should include the point 3, 0. And it should have 3 in the domain. So a little mistake on the answer key. So you can see that this answer key was handwritten. It wasn't generated by a computer. So yeah, guess there could be mistakes. I will take responsibility for it because I'm using it. But I didn't make the mistake. Another teacher made the mistake, and I'm just borrowing their work, so take it for what it's worth. Okay, all of these are also what we would call discrete because there's just a finite number of points in each problem. This one had 4 points. This one had 1, 2, 3, 4, 5 points. This one has 4 points. 1, 2, 3, 4, 5, 6 points. So all of these would qualify as discrete. It's not till you have infinitely many points that we get to the other type, which is called continuous. Okay, now we're looking at relations expressed as mappings. Again, ing on the end of a noun, it's called a mapping. Express the following relation as a mapping. So we're actually going to do a little drawing here. State the domain and range, determine if it is a function. So a mapping, you basically draw 2 ovals or blobs or circles or 2 shapes. You put all the domain numbers in one of the shapes, all of the range numbers in the other shape. Oh, we don't need to put 3 twice. So 1, 2, 3, 4, all of those went in the first shape. 5, 3, 3 again, -1, 5, 3, -1, all went in the second shape. Oops, I didn't mean to erase that. I'm going to erase all these little arrows. The one downside of Notability is I don't think I have a pointer. Oh yeah, I do. No, I don't have a pointer. So yeah, I do a lot of extra drawing and then erasing. Okay, anyway, so a mapping. Let me get back on track. So it's a diagram. You draw 2 shapes, usually they're ovals, put the domain numbers in one, the range numbers in the other, and then connect them. So 1 is paired up with 5, right? I'm sorry, -1 is paired up with 5. You draw an arrow from -1 to 5. 0 is connected with 3, so you draw an arrow there. 2 is connected with 3, you draw an arrow to that 3. And then -3 is connected, 3 is connected with -1. I just can't speak right. These little arrows up here are not part of the answer. I was just explaining. But what you have here is the mapping. Real quick, I'm going to go and check number 10. Where is it? Right there. Okay, so the teacher who made this went ahead and wrote these in numerical order. So -1 smallest, followed by 3, followed by 5. And then you'll see that the arrows, though, are still connected. So -1 is connected to 5, 3 is connected to -1, 0 and 2 are connected to 3. So even though our drawings look a little different, they're actually both considered the same. They're both correct. Okay, so domain. Domain is really the first oval. So it's -1, 0, 2, 3. Range is the second oval, 5, 3, -1. Is this a function or not? Now, this is a type of problem that does confuse a lot of students. The rule is you cannot use the same x value twice. So no x value can have more than one arrow coming from it. One arrow, one arrow, one arrow, one arrow. So the answer is yes, this is a function. The reason it confuses some people sometimes is there are 2 arrows going to the 3. So you say, oh, the 3, it's got 2 arrows, it's being used twice. But that's okay because it's a y value. You can use y values more than once. You cannot use x values more than once. So this is a function. The fact that the 3 has 2 arrows going to it is not relevant. So that should be the answer to number 10. And there it is. Yep, everything's the same. Okay, number 12. So draw an oval here, draw an oval here. The first oval, we're going to put the x values. Just for kicks, I'm going to put the smallest one in first, the next larger one in next, followed by the next larger one, followed by the next larger one. Had to write small to fit all those fractions in there. And then the range is all of the y values. Well, look at this. 2, 2, 2, 2. All I have to write in this bubble is a 2. And so now, each one of these connects to that 2. And there it is. What is the domain? The domain is everything in the first bubble. -1/2, 1/8, 1/4, 1/2. The range is simply the number 2. And is this a function? Yes, it is, because each x value is only used one time. Once, 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 once. Okay, let me check number 12. And, oh yeah, look, they made a little mistake here, had to make the bubble bigger. Yeah, but everything else is legit. It's all there. It's all right. Once again, all 4 of these, so you're going to do 9 and 11 in your assignment, of course. All of these are considered discrete. So I don't think you're going to be tested or quizzed on the word discrete or continuous. I'm just bringing it up over and over again. It's something that I'm supposed to mention to you. It's a thing. It exists. But it's not like a critical thing. It's more critical that you understand what domain and range mean, that you understand what makes a relation a function. So when is the answer a yes? When is the answer a no? Okay, now all of these are continuous. Continuous. They all have infinitely many points. So if we look at this shape, there's points all along here. Not only does it go on forever in both directions, up and left and right, but every single point is connected. Connected, another word for connected is continuous. So there's infinitely many points here. So what is the domain? Well, because this graph goes all the way to the left and all the way to the right, we can say that the domain is all real numbers. Every single number. It looks like it is going to go just straight up at some point, but it doesn't go straight. It keeps going outward. So this graph, would go to here, over 10, up, there's a certain height that graph reaches. You go over 100, a million, a billion, a trillion, negative a billion, negative a trillion. Every x value has a y value somewhere on this shape that just keeps going upward and outward to infinity. So all real numbers. Another way that this is sometimes written is negative infinity is less than x is less than infinity. That means the x, or the domain, goes from negative infinity to positive infinity. That's a way to write the answer as well. The range, remember range is all the y values. Now, does this function go up and down forever? Would the range be all real numbers as well? And the answer is no. This graph actually has a low point. It does not go any lower than 2 on the y-axis, but it does go up forever. So one way to write this answer is 2 is less than or equal to, not x, sorry, range is y, which is less than infinity. Let me check the answer key real quick, because there's another way to write this answer. I'm not sure if it's done here. Ah, yes. Okay. There is another way to write this answer, which I will show you right now. First, the domain. Another way to write domain is negative infinity, comma, infinity. That's the left and the right. So the left goes to negative infinity, the right goes to positive infinity. The range, another way to write the range is like this. Bracket 2, comma, infinity. This is the lowest number. Well, let's see, I used L for left. Should I use L for lowest? That might be confusing. I don't know what else to call it, though. I'll just write the word low. And then infinity is how high it goes. So we'll call this low to high. So how low does the graph go? 2. And a bracket means it actually touches the 2. A parenthesis means it doesn't actually touch. You can't reach infinity because it goes on forever. You'll never get there. So there's a parenthesis on infinity, but there's a bracket on 2. So the lowest point on the graph is 2. The highest point is infinity. So maybe I'll do this. Just a little extra note. Maybe I'll put it up here. So domain is going to be left. Oh, geez, could I try and do something right? Left to right, or it could possibly be bracket left to right. And then the range is low to high. Make that capital. Or possibly bracket low to high. So infinity always gets a parenthesis. There's other times you can use parentheses. If it comes up, I'll let you know. That's the range in the domain. All right, so where am I? I just got all confused. I got off track. We're still in the midst of number 14. Now, is this a function? So we need to know, is any x value used more than once? Let's look at a couple x values. This -2 right here has a point right there. So this is used once. Let's look at +1. There's a y value right there. It's used once. What about +3? It has a y value up here. It's used once. Number 8, could we guess what's going to happen? Eventually, you'll go up high enough that these two things cross, and that number gets used once. So a way to determine whether a continuous relation is a function or not, let me say that again. A way to determine if a continuous relation is a function or not is with something called the vertical line test. The vertical line test basically says if a vertical line can intersect your graph more than once, it's not a function. So either use your imagination or use your pencil and actually draw a bunch of vertical lines. You know, vertical means up and down, right? A bunch of vertical lines through the graph. If each one touches the graph once, then yes, this is a function. let's do a couple of these and I'll come back to this just to make sure you understand. Hearing it explained one time is not enough, but we've got lots of examples here. Okay, so number 16, the domain. This is a wave, and it basically continues this pattern forever. So our domain, how far to the left and how far to the right does this graph go? To the left, it goes to what we call negative infinity, and to the right, it goes to positive infinity. You could again call this all real numbers if you wanted to. Oops, I'm gonna have to plug in my pencil here. Now for the range is the lowest point to the highest point. So how low does this graph go and how high does it go? Let me see, let me erase what I did in blue here. What's the lowest point on this graph? It looks like -1. And what's the highest point? +1. So the range is bracket -1, +1, bracket. Again, they're brackets because these actually do go to the point -1. It reaches that value. It's not like infinity where you can never reach it. So that's why there's brackets there. And then is this a function? Let's draw infinitely many vertical lines through here. Each one is only going to touch the graph one time each. So yes, this is a function. All right, let me zoom out, scroll down, and check number 16. So domain, -infinity to positive infinity, range, -1 to, oops, there's another mistake. Doggone it, I'm going to have words with this person. This goes to +1, that's the highest point. And then is it a function? Yes. Okay. Next one. Where am I? Right here, number 18. So this is an interesting looking graph. I don't know of any particular name for it. I think you can just ignore that H that's right there. It's nothing at all. Okay, domain. So left to right. How far to the left does this graph go? It looks like 0. How far to the right does this graph go? It looks like it stops at 6. It actually touches those 2 points. So it's bracket 0 to 6 bracket. Range. Remember, range is lowest to highest. What is the lowest point? Well, if that's -6, I'm going to call that -7. Maybe it's -8. Maybe you have to guess here. Lowest point to the highest point. Okay, if this is 18, I don't know. Do you think we can call that 18? Looks to be a little higher than 18. Let's call it 19. So it goes from -7. I bet that's going to be -8. I don't know. I just have a feeling. And then is this a function? If we draw a bunch of vertical lines through it, every vertical line touches once. So yes, this is a function. Let's see number 18. Where is it? There we go. Oh, geez. So -6. That definitely goes lower than -6. I'm going to say we're right. -7. Up to 17. What? That clearly goes above 18. All right. I'm going to say our answer is better. And then is it a function? Yes. Okay. So as you're doing this for homework, when you check yourself, maybe take some of the answer key answers with a little grain of salt. Maybe there's a little mistake going on there. We'll just have to deal with that. Okay. Number 20. Domain. So these arrowheads are important. They mean the graph goes on forever. So if we're looking at left, right, the domain is -infinity, +infinity, because it goes forever to the left and forever to the right. The range, lowest to highest, is also -infinity to infinity because this arrow goes down forever and it goes up forever. Down is -infinity, up is +infinity. And is this a function? Our vertical line test, wow, everything's a yes so far. I hope we get to a no. Good grief. So yeah, every vertical line would touch it once. That means every x value is used once. So that should be number 20. Let's take a look. Number 20. And there we go. Check, check, check. All right, 22. This one will be different. This is a circle. Get some high quality education now. Hey, class, this is a circle. All right, domain, left to right. How far to the left does this circle go? How far to the right does it go? Well, it looks like it goes from -2 to +2. It actually reaches those values, so we put brackets there. The range, what is the lowest value? What is the highest value? Well, this is the origin 0, so 1, 2, -1, -2. So the range is also -2 to +2. And let me erase some of this. Now, is this a function? Let's do a vertical line test. Okay, I drew one vertical line and already this graph fails the test. It touches a vertical line twice. That means an x value is being used more than once. So here's our first example of a continuous function, a continuous relation that is not a function. So this is a no. We can draw more vertical lines. All that does is prove that it fails over and over and over again. But when it fails, it fails. You only have to draw a vertical line once to prove that it fails. All right, let's check number 22. So there, yep. Domain, range, no. Let's look at 24 together. Good grief, where am I? Right here. Okay, so this is a half circle. Domain, remember, is left to right. This point is the furthest to the left that it goes, and that is the origin. So it looks like 0 is as far to the left, but again, +2 is as far as it goes to the right. So bracket 0 to 2. The range is the lowest value to the highest. Well, the lowest value is right here. The highest is right there. -2. Nope. That's going to be a bracket, right? Because it actually touches the -2. And then +2 bracket because it actually touches up there. Or it reaches that value. And then is this a function? So think to yourself, is this a function? Okay, I'm going to say no. And the reason I can say no is I can draw a vertical line that intersects more than once. Therefore, an x value is used more than once. No, it's not a function. So number 24. Where am I? There it is. 0 to 2, -2, 2, no. I'll just make up another one real quick. Let's do, here's my x-axis. Oh, wait, you know what I can do? Plus, stickies, grid. Sort of makes graph paper for me. I don't love it, but we'll make it, we'll call it good enough. Let me switch to black pen. Come on, I need to write on you now. This will be my x-axis. This will be my y-axis. I'm sure a lot of you are done and already started your homework. Oh well. Let me draw a graph that looks like this. It goes from here, zig, zag, and then horizontal. So this is a real funky graph. Domain, range, function. What is the domain? Okay, the farthest point to the left, -1, -2, -3. The farthest point to the right, it goes forever, so that's infinity. Bracket -3, comma, infinity. Range, what is the lowest point? The lowest point is right here, -1, bracket -1, comma. What's the highest point? I think that's the highest point right there, which is 2, bracket. And is this a function? Yeah, no matter where you draw a vertical line, every vertical line only touches once, so this is a yes. Obviously, there's no answer key because I just invented this problem off the top of my head. But there, just in case you needed a little more work. Okay, wow, that was a lot. Do your best, do the odds. Please contact me if you have questions. If you hung in here through the whole video, bless your heart. Otherwise, good luck. contact me through the normal means if you have questions.